Okay, gang, we're on to the quotient rule, and as you guessed, I am not going to give you the rule. I'm going to make you come up with it yourself. So, here we go. Quotient means divide, and that's why it says when dividing monomials. So, we are going to do division. And you might recall from our last little piece, I did something right here, but they weren't like bases. These were different bases. So, let's see what happens. So, we're going to take this first one, x to the fifth over x to the third. And we are going to expand it out. So here we go. X to the fifth. Well, remember that just means we have 1, 2, 3, 4, 5 x's on top. And on the bottom, x to the third means we have 3. We're going to try and stack them up on top of each other as best we can. Sometimes we can do this, sometimes we can't. It just kind of depends. I want to remind you, if I told you, if we were solving a problem and I did 4x over 4x, if you were to put that in your calculator, 4 divided by 4 is 1. And a lot of times you would even mark it off and say, oh, like it goes away. It kind of does, but it still equals 1. When you do division, the same thing's going to happen. When you have the same base over the same base, x over x, they are going to cross out. Everywhere they line up, they cross out and they become the number 1. Well, 1 times 1 times 1 is just 1. All I am left with is 2 x's on top. Well, remember, I don't want to say the answer is xx. I want to say the answer is x squared. Now, what happens to the denominator? Well, it becomes a 1. And remember, every number that you write is always over 1. 6, I can make it a fraction by putting it over 1. 10, I can make it a fraction by putting it over 1. But a lot of times, well, we don't really want to do that. We just want to say the answer is 6. We don't want to do that. We want to say the answer is 5. So we don't really want to say the answer is x squared over 1. Instead, we just want to say the answer is x squared. Okay, now the next one on this one we are jumping to is a little bit harder, but I think you're ready for it. Like, you got this. So what we're going to do is draw a line, and we are going to expand this out. All right, that's p times p times p times p. That's q. 1, 2, 3, 4, 5, 6, 7. How many of you can never make a good q? I don't know. I guess that's a good q. Okay, on the bottom, 1p, and we're going to put the 1p underneath the first one. And the q's, it's 2. I'm going to come over here, and I'm going to put it underneath the q's. So I do kind of spread it out a little bit. All right, everywhere they double up, we're going to cross them out. Those double up, q over q, q over q. Okay, what am I left with? 1, 2, 3 p's on top. So p to the 3. 1, 2, 3, 4, 5 q's. And there it is. So, time to figure out what did we do? How did I get from 5 over 3 and I got to 2? Here I went, let's look at the 7 and the 2. 7 and 2 on the q's, and I got to 5. What are you thinking? I'm thinking 5 minus 3 is 2. And I'm thinking 7 minus 2 is 5. What did I do here? Remember, if it doesn't have an exponent, it's understood that it's a 1. 4 minus 1 is 3. Oh, look at that. Okay, so we are subtracting. What's the quotient rule? I'm going to say that if I have x to the a over x to the b, I'm going to subtract. So that will be a minus b. Now, we're not going to do the next part. We're going to figure this out. And I think the next one, here we go. So remember on the last section where I broke the numbers apart? I kind of like to do that here as well. And I like to say 28 over negative 7. And then I like to do m to the 4th. And then I like, when it doesn't have an exponent, I like to put the exponent because it helps me. M. Oh, you know what? That 6 right there is not supposed to be a 6. we're going to make that 6 a 3. Oh, and that n, we're just going to mark that one off altogether. And we're just going to say n to the 1. Okay. So why would I break this apart? Like what? I don't understand the difference there. I pull the numbers out to the front because I'm going to use my calculator. And I'm going to say alpha y equals, and I'm going to say 28 over negative 7. Okay? And that's negative 4. Because negative 7 goes into 28 negative 4 times. You divide. It is so easy when you're doing these to switch and start trying to subtract. This is division. The numbers right there, that is division. 28 divided by 7 is negative 4. Now, 4 m's on top and 3 on bottom. Well, okay, I probably should have done this anyway. You don't need to rewrite it. You can just watch. That's 1, 2, 3, 4 m's and 1, 2, 3 m's. I'm going to mark off when they add up, match up, and I just have an m. So I've got negative 4 with an m. And then on the n, n over n, bam, they're gone. They cancel each other out. So I just have a 1. So the only thing left on this one is negative 4 to the m. Now, if you're looking at this and you're like, wait, well, what if we'd have done it the other way? I will go back on another page and I will rework that one with that problem right there. But for right now, change that m to a 3. What I want right now is the exponent to be smaller on the bottom or the same. Okay, I don't want to jump to a big one there just yet. All right, and the next one works. We can do the next one. Oh, you know what? I need to go fill it out. What did we do right here? We divided the coefficients. I'm going to go back up here. We divide. How do we solve it? We divide the coefficients and then we simplify the exponents. I wonder if we should have said we subtract the exponents, but I mean simplify is fine, but you could say subtract as well. You could say subtract right here. On the other page, power rule, we could have said multiply the exponents. Just something you could have done. Okay, here we go. I'm going to leave you just a second. Let you kind of look at it. Now I'm going to break it apart. And I'm going to say negative 15 over negative 3. And then I'm going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And a z. And then I'm going to have 1, 2, 3, 4, 5. 1, 2, 3. And no z's. All right. Negative 15 divided by negative 5. 3. Oh, I said the answer is 5. Marking off where they add up. Okay, so I've got a x, I've got y squared, and I've got a z. All right, so there we go. Okay, quotient rule. Let's do one more. Okay, let's do x to the third squared over x to the let's do the fourth. X to the fourth. Okay, so you're like, oh my gosh, look at that one. Yeah, that one's a little scary, huh? Okay, let's do parentheses first. You know PEMDAS, parentheses first. So a power to a power, we multiply. So that would be x to the sixth. Over, we still have x to the fourth. Well, 6 x's on top, 4 on bottom. Mark them off where they match up. Or 6 minus 4 is x squared. Now, the problems are just going to get more complicated as you go, but this is the foundation of it, and hopefully that will help you get through your IXL skills.